Doing methodical work in this environment takes perseverance.
This is why I'm a terrestrial archaeologist, and Morgan and Jesse Halligan, they're all like, come dig, come out and get scuba up and go. I'm like, you guys got like water moccasins and gators? They're like, yeah. I'm like, no, I'm good, dog. I'll stick with my land snakes that I can run from.
In the low visibility of Aucilla waters, you wouldn't even see a snake until it was right next to you.
Something about the dark water is just really, really gorgeous, really, really pretty. It's actually really nice that you can't see, because you're underwater, you're diving, you have all of this stuff on your back, the scuba tank and everything, you have surface to air hooked up as well, and you're excavating in this 1 by 1 meter square that's directly in front of you. All you need to do is see about 6 inches in front of your face, and that's all you need to focus on. You don't need to see everything else around you, and I really like it because it is so dark, you're not able to get distracted by fish floating around, or maybe there's a manatee in the distance or anything.
It's actually some of the best excavation conditions in my opinion, right? I have been doing archaeology since I was 12 years old, so more than 30 years now. So we dig in square holes, 1 by 1 meter, just like our terrestrial counterparts.
You can see by the flatness of the riverbank that they've excavated several feet down. When they find something of interest, they bag and label it, noting its location in the stratigraphy.
You want to dig slowly, because being slow is being precise, especially underwater. We're never in a rush, and just being down there, only being able to see like 6 inches to a foot in front of you really helps you focus on what's immediately in front of you, allowing you to find these things in situ.
It's slow, steady work, with no guarantee of finding an aha artifact. But archaeologists are drawn to the potential of this river and its many sinkholes.
The future of submerged prehistory, at least in Florida, probably the entire American Southeast, is still within the Aucilla River. But to date, only 3 archaeological sites have been excavated and well reported.
The land between Tallahassee and Gainesville is pocked with sinks and springs, fresh water that supports a diversity of life. You could see why humans and large mammals would be drawn here. Except, this is not what it looked like when humans first arrived in Florida.
So we're standing at the head spring of the Wassissa River, and this spring run goes down to the coast and eventually flows into the Aucilla River. And so 15,000 years ago, when the first peoples came to Florida, the climate was a lot different. It was the end of the Pleistocene, the glacial epoch. At the end of the Pleistocene, there was a lot of glacial ice. This transfer of water from the oceans to the land surface resulted in sea level being about 300 feet lower than it is today. So places like the Wassissa Spring here, that water table would be lower as well. And so this probably was a sinkhole.
Ichotechny Springs State Park, where we are now, looking at the Simpsons Flats site, we have this mastodon that's kind of eroding out of a bank, but at the time that this mastodon died, it would have been high and dry. Page Lassen is in the Aucilla River. It would have been much lower at the time, but again, freshwater source for the megafauna and for the humans. So.
The modern Aucilla River sort of is essentially a fairly shallow, small, flowing body that's sort of connecting a series of sinkholes.
You've got these major rivers in Florida that are cutting across like a limestone platform, and in that limestone is a bunch of great rocks to make stone tools. A bunch of great animals running around if you're a hunter-gatherer.
From about Tallahassee over to the Swanee River, it's all underlain by limestone. So circulating groundwater in the limestone would have caused caves to form that would have collapsed, making your sinkholes.
To help us imagine what an Ice Age Aucilla would have looked like, we visit the Aucilla Sinks section of the Florida National Scenic Trail. Here, the river enters the aquifer, appearing in a series of sinkholes before emerging just north of the Page-Ladson site.
A lot of these mid-channel sinkholes that are now submerged by the flowing river, my research has really been showing that they're collapsed sinkholes, which is exactly what the Aucilla sinks are. Interestingly though, the Aucilla sinks are more recent, and because they're more recent, they've had a lot more water flowing through them. And so we don't really see too much old deposits within the Aucilla sinks themselves. It's really cool to think of them though as a modern environmental analog to what the sites submerged by the Aucilla River actually would have looked like during the late Pleistocene.
And we believe that when sea level was lower, water tables were lower, most of those sinkholes still had water in them.
Beasts that the people would be hunting would be drawn to the water in the sinkhole. They would come here and it would be a focal point for hunters.
When sea level was lower, those rivers that flowed in clays and sands and gravels would have downcut deeply into their beds. And we had places like the Aucilla River where there are 10-foot or 15-foot high vertical banks with a creek in the middle of it, and you could run the elephant off into that and just spear it at your luxury.
So we are seeing clusters of really old archaeological sites in Florida around these karst sort of formations.
It's fun to think about that the same features that attract us to places today hold true, as you rewind the clock through time. And so as we go back a couple thousand years and more thousand years, we keep finding that, freshwater sources are places of human activity. They also happen to provide some great preservation.
Florida, we are a state of water. We have the second longest coastline in the contiguous United States.
So water is not necessarily the great preserver of organic material, but it's the inorganic layers of sediment that exist below the water that create pretty much an ideal stasis-like condition that can preserve delicate organic materials for thousands and thousands of years.
Florida's geology provides an abundance of locations for water and sediments to preserve materials.
Historically, we have found sinkholes are an excellent place to preserve fossils, whether they're wet or dry. One of the factors that harms bones are natural acids that form as plant remains decay. As the groundwater passes through humus and decaying leaves and things, it will naturally pick up some of that acid. But being in a sinkhole environment, that limestone just acts as a natural buffer. It's just like you take Tums or an antacid, so they neutralize those acids. And so the geochemistry of sinkholes is really good for preserving fossils.
Did more mammoths and mastodons live in Ice Age Florida than the rest of the continent? Were there more people here? Maybe, maybe not. But more bones and artifacts have been preserved here.
It's just that the sinkholes, the freshwater springs, allowed that evidence to be preserved. So going back to that, geology determines so much about what we can ever know about people in the past. This is just a unique and completely unique geological situation that gives us a chance to look at what it would have looked like everywhere.
That unique geology extends out into the Gulf of Mexico. And once, so did rivers such as the Aucilla and St. Marks.
You can kind of see the modern day river channels here. There's the St. Marks, there's the Aucilla, and you can almost kind of see this little finger where the Paleo-Aucilla channel would have been.
What is the Paleo-Aucilla? And why is Morgan looking for archaeological sites out here?
The state of Florida is a large limestone platform, and currently about half of that platform is underwater. And we call that the continental shelf. And the shoreline, back 15,000 years ago, was out there.
It was an entire coastal plain that is now completely submerged, and it would have been a continuous landscape, right, with what is now the remaining bit of Florida that's left.
With sea levels being so significantly lower then, it seems like a very fruitful exercise to kind of figure out what did that landscape actually look like when people were here during the Paleo-Indian period.
It's not always a cooperative environment.
Yeah, it got a little choppy out there, so we came about 2 miles back further in.
If you have a week, 3 days are automatically gone because of bad weather. So there you're just looking at 2 days of actual work. And then if you're spending half the day trying to find the site, or bad weather comes in, it can really throw you off.
So we're kind of surveying this whole landscape for sites. Around 5,000 years ago, 3,000 years ago in here, 5,000 where we were, this was all dry land. So everything you're looking at was, you know, indigenous peoples could have and did use it, and it was just like any other part of Florida. Rivers, springs, streams, trees, you know, grasslands.
To find sites out here, archaeologists go to the types of places where humans, even modern humans, have always gone.
So we're cutting across both the St. Marks and the Paleo-Oscilla channels to try to figure out where those channels would have been and map sites off of them. There was a big confluence out here, which is really good because those kinds of confluences are, you know, obvious physiographic features that prehistoric peoples would have mapped onto. I don't think there's a single river confluence in Florida that's not an archaeological site. I'm standing at the confluence of the cool, clear waters of the Wassissa River, which is making its way down here, into the dark, slightly warmer, tannic waters of the Oscilla River. And we're standing at the confluence of these two rivers, and just downstream of us is Page Ladson.
Like at Page Ladson, archaeologists had long stopped working offshore.
There really hasn't been a whole lot of work done out here. I mean, in the 80s and 90s, there was a lot of targeted kind of work that really pioneered some of the archaeology out here on these submerged landscapes.
The generation that came before, like Dr. Michael Fott, Dr. James Dunbar, they were from that generation in the 70s and the 80s and 90s who began to really grasp the potential and to do this in a systematic manner.
As I learned that sea levels came up and the continental shelves were exposed, I became enthusiastic about finding sites on the continental shelf. And there weren't a lot of examples around, and my major professor, Vance Haynes at the University of Arizona, mentioned Florida. I had done a study in geology about where's a good place to go where the sediments are not covering the old topography, where the ocean might be gentler, and where there were a lot of Paleo Indians. And Florida was a clear, no-brainer. So in 1986, I flew out on my own nickel and met Jim Dunbar, who's a famous archaeologist here in Florida. And we went out offshore for 3 days in little boats, a couple of little boats, and we found 3 quarry sites and Paleo Channel out on the offshore. So immediately there was success.
Offshore work is starting again. But first, archaeologists have to relocate the sites.
It's very typical, surprisingly, even today, to go out in the Gulf of Mexico on a small boat with a decent GPS unit and still have a hard time relocating a known archaeological site.
Kind of what I found is that the navigational chart that they were using at the time has a substantial offset, especially in the deeper water, from modern bathymetric data.
Maya Welch's undergraduate honors project was to correct the offset in the charts. Working with Michael Fott, Maya was able to help Morgan's team find the old sites. The hardest to find were the smallest sites. Maya was diving offshore with Morgan when Morgan found this point. Not every site will have an obvious artifact.
When you think of underwater archaeology, you think of shipwrecks. Those are very big. They show up in remote sensing equipment very easily. But some of these more ephemeral sites, which may be lithic scatters or a mortuary pond that's very small and you're in the big, big ocean, they're very difficult to find.
We don't have a written record to kind of tell us, the details about these people and about their lifeways. We don't have an X on a map somewhere where we just know exactly where to look. We honestly don't even know what we're gonna find until we find it.
You can go offshore just about anywhere in the world and you know you're in a high energy environment. And you know that trying to find something left behind by people who lived thousands of years ago, people who were not building monumental architecture and were not building, bridges and roadways.
How are we going to find evidence of their life on Earth?
So one of the things I always tell students is look for things that are in the same place that shouldn't be there together. You see a pile of oyster shell, and intermingled with it, you see bits of stone tools, maybe some charcoal, a deer bone. All of a sudden, you've got a bunch of things that are not like one another, that are occupying the same physical space. These are from very different environments, right?
In that scenario, you can envision a camp where humans were harvesting oysters and hunting deer. They left this waste behind, and over time, the site was claimed by the Gulf.
The last glacial maximum was about 20,000 years ago. So when people moved here, the glaciers were receding. They were melting and flowing into the sea. So people that lived on the coastal plain of Florida were probably experiencing sea level rise at a pretty rapid rate. So anybody that lived at the coast would be rapidly moving inward over their lifespan.
Those environments would not have been entirely stable.
Archaeologists have to find signs of people who lived on a coast that was always on the move.
So we're very curious about where the coastline was at a given point in time. And how do you determine that? We've got like bathymetric data, sure, but a lot of those models are based on dating of specific types of materials.
Knowing the taxa of shellfish is important because it can tell you whether or not the shellfish were in a marshy region or if they were closer to the sea.
So if you've got oysters appearing at sites, that's going to let you know that water is becoming brackish. You can look at mangroves, which can also be in more brackish areas, like in those intermediate zones.
Oysters and mangroves grow right along the coast. So, if you find fossil mangroves or oysters at a site offshore and radiocarbon date them, you can find out when that location was the coast. Oysters thrive in a mix of fresh and salt water, usually in or near the mouths of rivers.
The river system likely started flowing around 5,000 to 4,000 years ago. Before that, there were these kind of interconnected, isolated sinkholes, and likely before that, the river system was flowing probably around 50 or so thousand years ago as well.
Rising water on the Oscilla helped preserve sites.
You just kind of imagine water just kind of coming up slowly in these holes. It's not a destructive process, it's this kind of gradual inundation.
And so it's the changing from these isolated sinkholes to the modern river system with erosion happening during that and in between those time periods that really only creates a couple of unique zones where we have those deposits dating to 10 to 15,000 years ago. And so we don't actually know the exact nature of why they're only in some areas, and that's what my dissertation is really trying to focus on.
So Michael, we're not going to want the dredge for the first part of it.
Nick is excavating a site on the Oscilla River, hoping to find the next Page Latson. That crew found plenty of fossils, but not many artifacts in their first year.
So, when we worked there, what we found was mastodon bones, a couple bison bones, some camel bones.
But not many artifacts. It was a cause of stress.
Like, oh my God, I'm never gonna finish, I'm not gonna have a dissertation, Mike's gonna be super disappointed with me.
Jesse deserves so much respect for persevering through it. I think any sane person would have given up. I'm not saying Jesse's insane, but it takes a particular kind of person to just keep at it.
It taught me like the most important part about underwater archaeology, which is that you have to be really resilient and creative.
Dr. Mike Waters was actually here on site that day. It was kind of like you couldn't have written a better story. He was probably going to leave in a couple days, and I think he had actually said, if we don't find anything this year, we're calling it quits. You know, like we're done with Page Latson.
I'll never forget the day we were sitting on the boat. I was sitting there with Dave Thulman. We were watching, the bubbles and everything on the surface, and Morgan came boiling to the surface and said, "We found a biface." I looked at Dave and I said, "Oh my God, that's more than I ever thought we'd ever find."
And there was this super dramatic moment where everybody wants to see it,
We found an unambiguous stone knife that really demonstrated, hey, this is really here in this stratigraphy. We were able to gather tons and tons of material to radiocarbon date.
And I said, well, pretend the biface is the nucleus of an atom and collect samples from all around it for radiocarbon dating so that, you know, we're ironclad. It was overkill on the dating, but it had to be done to demonstrate that that material was definitely in situ.
So it was able to really kind of nail down that these earlier investigations at the site had been correct on the ages of the stratigraphy and that there were cultural materials in that stratigraphy that they had reported, right? We got interviewed by the New York Times and the Chicago Tribune and these really old school kind of fancy papers, and there was an article in National Geographic, and it was really exciting because it got people really excited about archaeology and what the possibilities were, and it made people who didn't ever think about what was going on in the end of the last ice age in the Americas all of a sudden they have a chance to encounter, hey, what, there were people here 14,000 years ago?
It sparks the imagination. Humans coexisted with mammoths and mastodons for 1,000 years at least. And, over generations, they would watch Florida transform